Hello students, how are you and how's your study going on? Well, this is lesson number 7 and here we will discuss some more important questions of type B. Previously in the lesson number 6, we solved some numericals of type A. Okay, this is the last numerical of type A. Let's solve it. A hot plate of an electric oven connected to a 220 volt line has two resistance coils A and B, each of 24 ohm resistances, which may be used separately in series or in parallel. What are the currents in the three cases? Okay, see, we are given the two resistances of the coil A and B, each of 24 ohm resistances. Now, these are used separately in series or in parallel. Now see here, this is the first case. We can see here the resistance has been connected separately. So this is the second case where resistances are connected in series. And this is the third case where the resistance is connected in parallel. Now we have to find out the currents in the three cases. For first case we will take the current I1. For the second case we will take I2. And for the third case we will take the current I3. Okay, now write the given values. The voltage V equal to 220 volt, resistance R equal to 24 ohm. We have to find out current when coils are used separately, I1, current of series combination and current of parallel combination. So formula we will be using here, V equal to IR, RS equal to R1 plus R2 and 1 by RP equal to 1 by R1 plus 1 by R2. Let's solve it now. For case 1, coils used separately. So according to Ohm's law, we know that V equal to I1R. Here we are taking I1 because here the current when coils are used separately. Okay, that's why it is I1. Therefore, I1 equal to, rearranging it, we'll get V by R equal to 220 by 24. Therefore, your current I1 will be 9.166 ampere. Now in case 2, coils in series. Now see, the total resistance in series is Rs equal to R plus R. So add it, Rs equal to 24 plus 24. Therefore your Rs equal to 48 ohm. Now according to Ohm's law, V equal to I2 by Rs. Okay, rearrange it and put the values. We will get current I2 equal to 4.58 ampere. Now in case 3, when coils are in parallel, total resistance in parallel, write the formula 1 by Rp equal to 1 by R plus 1 by R. Therefore, put the values. We will get the value for Rp equal to your 12 ohm. Okay. Now according to Ohm's law, V equal to I3 R into Rp. Rearrange it, I3 equal to V by Rp. We will get 220 by 12. Therefore, your current I3 will be 18.33 ampere. Is that clear? So your answer is, the currents flowing through the coils when they are used separately in series and in parallel are 9.166 ampere, 4.58 ampere and 18.33 ampere respectively. Okay, now these numericals are of type B. So formula we will be using here. First is V equal to IR and the second is resistance equal to rho into length by A. Here A is area, that is pi r square, A equal to pi r square.
कोई भी सपना साकार करने के लिए सबसे जरूरी है सही कोच का होना। चुनिए नख्यात्रा को और करें अपनी 4th to 12th classes and government preparation का सपना साकार। Download the app now.
Question number 1. How much current will an electric bulb draw from a 220 volt source if the resistance of the bulb filament is 1200 ohm? B. How much current will an electric heater coil draw from a 220 volt source if the resistance of the heater coil is 100 ohm? So there are two circuits. For the first circuit, R1 equal to 1200 ohm and the potential difference V1 equal to 220 volt. We have to find out the electric current I1. Now for the second circuit, the resistance R2 equal to 100 ohm and the potential difference V2 equal to 220 volt. We have to find out the current I2. Now write the given values. For V1 equal to 220 volt, R1 equal to 1200 ohm, V2 equal to 220 volt and R2 equal to 100 ohm. Now we have to find out the current I1 and I2. So the formula we will use V equal to IR. Now let's solve it. V1 equal to I1 into R1. Now by putting the values and then rearranging it, I1 equal to 220 by 1200. By cancelling it, we will get 22 by 120. Again by cancelling it, we will get the value for I1 equal to 0.18 ampere. Now for V2, that is for the second circuit, V2 equal to I2 into R2. And therefore 220 equal to I2 into 100 ohm. Now rearrange it, I2 equal to 220 by 100. Cancel it and we will get I2 equal to 2.2 ampere. So the answer is current through bulb is 0.18 ampere and the current through heater is 2.2 ampere. Alright, question number 2. The potential difference between the terminals of an electric heater is 60 volt when it draws a current of 4 ampere from the source. What current will the heater draw if the potential difference is increased to 120 volt? Okay, so write the given values. The potential difference V equal to 60 volt. The current I is given 4 ampere. The increased potential difference we will write it as VI is equal to 120 volt. Now we have to find out the current I. Okay. So for the formula we will use V equal to I into R. Now let's solve it. V equal to IR, therefore R equal to V by I. Now by putting the values, R equal to 60 by 40, we will get R equal to 15 ohm. Okay, now see, when the V is increased to 120 volt, then now see here, potential difference V is increased, but R, that means your resistance, will remain constant. Okay, so I equal to VI by R. Now put the values. For VI it is 120 and for R it is 15. Now by cancelling it, we will get I equal to 8 ampere. Okay, so the answer is the current in the heater is 8 ampere. Is that clear? Alright, question number 3. Resistance of a metal wire of length 1 meter is 26 ohm at 20 degrees Celsius. If the diameter of the wire is 0.3 millimeter, what will be the resistivity of the metal at that temperature? Okay, now see here. So this is a wire of length 1 meter, diameter is 0.33 millimeter and the resistance is 26 ohm. Okay, so write the values. R equal to 26 ohm, L equal to 1 meter, diameter equal to 0.3 millimeter. Now write the radius. Therefore our radius will be your 0.15 millimeter. Now since it is in millimeter, convert it into meter. Therefore it will be 15 into 10 to the power minus 5 meter. Now resistance equal to rho into L by A. Here by rearranging it, rho equal to R into A by L. Now put the values. For R we know that it is 26 into, now A equal to, we already know, pi R square. So write the value for pi 3.14 into, now what is the radius? 15.10 to the power 5. Now square it and divided by L, that is 1. So we will get 26 into 3.14 into 225 into 10 to the power 6, rho equal to 1.84 into 10 to the power 6 ohm minus 6 ohm. Okay, so therefore the resistivity of metal is 1.84 into 10 to the power minus 6 ohm meter. Don't forget to write the unit. Okay, it is ohm meter. Okay. Now question number 4. A wire of given material having length L and area of cross section A has a resistance of 4 ohm. What would be the resistance of another wire of the same material having length L by 2 and area of cross section twice A? So see, this is the first wire having length L and area of cross section is A. This is the another wire of the same material having length L by 2 and area of cross section is twice A. So now for the first wire, R1 equal to rho into L by A equal to 4 ohm, because it is given in the question 4 ohm. So mark it as equation 1. Now for the second wire, R2 equal to rho L by 2 by twice A. So 1 by 4 into rho L by A. Now solve it, 1 by 4 into R1. Now see, we are replacing this rho into L by A by R1. And from where it is coming? It is coming from equation 1. Okay, so 1 by 4 into 4 equal to R2 equal to 1 ohm. Therefore, the resistance of new wire is 1 ohm. Okay. Question number 5. When a 12-volt battery is connected across an unknown resistor, there is a current of 2.5 milliampere in the circuit. Find the value of the resistance of the resistor. So write the given values. The potential difference V is 12 volt. The current is given 2.5 milliampere. Now convert it into ampere. So while converting, we will multiply it with 10 to the power minus 3. Now we have to find out the resistance. So therefore, the formula we will use, resistance equal to V by I. Now put the values, R equal to 12 volt by 2.5 into 10 to the power 3. Therefore, R equal to 4800 ohm. So the value of the resistance of the resistor is 4800 ohm. Alright, now question number 6. Let the resistance of an electrical component remains constant while the potential difference across the two ends of the component decrease to half of its former value. What change will occur in the current through it? Okay. Now see here, according to Ohm's law, we know that V equal to IR. So now you rearrange it, I equal to V by R and mark it as equation 1. Now the potential difference is reduced to half. Read the question again. See here, the potential difference across the two ends of the component decreases to half of its former value. Okay, now the new potential will be V dash equal to V by 2. Okay, and mark it as equation 2. Therefore, the resistance remains constant. Now the new current I dash will be V dash by R. Therefore, new current I dash equal to V by twice R. Now from where it is coming? It is coming from equation 2. Okay. Now put the values 1 by 2 into V by R. Therefore, I dash equal to 1 by 2 I. Okay. So see here, the current through the component will also become half. Is that clear? Okay. Now the last question number 7a. Draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2 volt each, a 5 ohm resistor, an 8 ohm resistor and a 12 ohm resistor and a plug key, all connected in series. Second question is, redraw the above circuit putting an ammeter to measure the current through the resistors and a voltmeter to measure the potential difference across 12 ohm resistor. What would be the readings in ammeter and voltmeter? Now see for 7a, this is the diagram of the circuit consisting of a battery of 3 cells, that is 2 volt, is of 2 volt. This is the plug key and these are your resistors 5 ohm, 8 ohm and 12 ohm, which all are connected in series. Now this is the circuit diagram for 7b. So see here, since all these are connected in series, we are asked to place the ammeter here. So we place the ammeter here and the voltmeter here so that we can measure the potential difference across 12 ohm resistor. Is that clear? Okay. Now see here, since all the 3 resistors are in series, therefore the total resistance will be, add all the resistors, we will get 25 ohm. Therefore current equal to I equal to V by R. Now put the value 6 by 25, we will get 0.24 ampere. Across 12 ohm resistor, the potential difference V equal to I into R. Put the values here, 0.24 into 12. We will get 2.88 volt. Okay. So the answer is ammeter reading equal to your 0.24 ampere and the voltmeter reading equal to 2.88 volt. Okay students, we are done for today's lecture, and if you want to do live classes with me and to clear your even small doubts, then why don't you download our app Nakhyatra. To download it, the link is given in the description box. You can check it out. Okay guys, bye for today. Thank you.